In this video, we're going to talk about 1.1 Day 1, an introduction to radians. Before we can talk about radians, we need to talk a little bit about angles, just a little bit of review from geometry. So we know what an angle is. It's when we have two rays that share the vertex and they intersect. So we have, a couple of angles drawn up here. But the terminology that we need to remember is that the initial side of an angle is where you start the measuring. So where you start measuring. So when you go to start measuring an angle, where you start is your initial side. The terminal side is where you stop measuring. Where you stop measuring. So if we look up here, these two things, the initial side, you can see the arrow going from the initial side up to the terminal side, same thing over here. We're going to be doing a lot with coordinate geometry, angles on the coordinate plane, so we usually want to have these things in standard position. So here's an angle in standard position here, and our definition would be, a standard position would be initial side must be on the positive x-axis. So it's always going to be right here for our initial side. Now there's two types of angles. We're going to have positive angles and negative angles. Both of these here are going to be positive angles because they open up counterclockwise. And then negative angles are going to open up clockwise. So a couple other little bits of definitions before we can really start playing around with these things. We're going to need to know what coterminal angles are. So if you know what the prefix co means, coterminal angles are going to share a terminal side. Now, we could have infinitely many coterminal angles. So if we look at the picture here, this is just showing us clockwise, so this is a positive angle, this is a negative angle. These are not coterminal because they don't end at the same spot. But if we look at these two pictures, these are coterminal. So we can have a positive angle and a negative co-angle. Or we could have a positive angle alpha, and if we go all the way around and then end up here, that's also coterminal. So really, we could have infinitely many coterminal angles because we could just keep circling around as many times as we want before we end at that coterminal angle. So the new stuff that we might not have seen before is this thing called a radian. And a radian is just another way to measure angles. So just like we have degrees Fahrenheit, degrees Celsius, Kelvin, those are all different ways to measure temperature. We have radians as another way to measure angles. So by definition, 1 radian is going to be the measure of the central angle theta, so this little thing right here is theta, that intercepts an arc S equal to the length of the radius of R of a circle. So what that means algebraically is theta equals the arc length divided by the radius. Now if we're going to have 1 radian, the arc length is going to be the same thing as the radius. So we'd have S over R. Well, if S is R, we have R over R1. So theta, our radians would be 1. But more practically, how we're going to think about our radians, it's just the ratio of a circle's circumference. Take it up by the intercepted arc. So if we think about a circumference of a circle, we know it's going to be 2 pi times the radius. But we're going to try to make the radius 1 just to make our lives easier. That's how we're going to think about these things. So all the way around it's just going to be 2 pi. So then we can think if we go just halfway around the circle, well, if all the way is 2 pi, halfway is going to be just pi. If we go a quarter of the way, well, a quarter of the way around is really halfway to pi, so pi over 2. Then we can think about pi over 3, pi over 4, pi over 6. These are going to be the ones that we have to have memorized, and going the pi over 6s all the way through 2 pi, and the pi over 3s and pi over 4s also going all the way to 2 pi. But we're going to have plenty of time to have these memorized. But that's how we're going to think about radians, is what portion of the circumference are we looking at. So let's think about radians, coterminal angles, and all of that stuff. So it says find the negative angle that's coterminal to theta equals 3 pi over 4. So if we think about a circle, we know that pi is halfway around. So pi would be over here if we go this way. So if we cut that in half, we get pi over 2 right here. If we cut that in half, this would be pi over 4. So pi over 4 is going to cut the quadrants in half. So we have 3 pi over 4 over here. So the angle that we're trying to find that's coterminal to is this angle right here. So to find the coterminal angle, we're going to need to start the negative coterminal angle. We're going to need to start here, go all the way around, and then go to there. So if we think we go from here halfway around the circle, that's going to be a negative pi. And then we have to go halfway through this quadrant, so that's another pi over 4. So we're thinking we've gone in the negative direction, a pi and a pi over 4. So the negative coterminal angle is going to be negative 5 pi over 4. Right, so we've gone a pi here, then we went another pi over 4, so our negative coterminal angle is going to be negative 5 pi over 4. We can also think about complements and supplements. So if we think about 2 pi over 5, so 2 pi over 5 is going to be somewhere in the first quadrant, but we don't really need to think too much about exactly where it is. We just need to know what is the complement going to mean and what is the supplement going to mean. Well, we know the complement means in degrees that they add up to 90 degrees. Well, if we think about a 90-degree angle, we know it's going to hit this quadrant right here. And we just saw a second ago that we call that pi over 2. So for the complement, we need to think 2 pi over 5 plus what angle equals pi over 2. So that's going to be pi over 2 minus 2 pi over 5, which is going to be 5 pi over 10 minus 4 pi over 10 if we get our common denominators. So the complement is going to be just pi over 10. So the supplement, we got to think, well, originally that would be, when we did this before, 180 degrees. We know 180 degrees is the same thing as pi. So we want to think about 2 pi over 5 plus what angle equals pi. So we're thinking pi minus 2 pi over 5. So that's 5 pi over 5 minus 2 pi over 5. So 3 pi over 5 is going to be the supplement. So complements and supplements work the same way. We just have to know that the 90-degree angle is going to be equivalent to pi over 2, and 180 degrees is going to be equivalent to pi. Now, these are pi over 2 and pi are two angles that you're going to need to have memorized, but if you forget, we do have a way to convert between degrees and radians. So if we're going to convert from degrees to radians, so you guys are very familiar with degrees, if we want to turn that into radians, we want to say the degrees is going to be, so degrees times pi divided by 180 is going to give us our radians. So equals radians. And then to go from radians to degrees, if you want to do that, we can say radians times 180 divided by pi is going to equal degrees. So degrees times 180 over pi, if you think about what we just said with pi and 180 being the same thing, 180 degrees times pi divided by 180. So 180 pi over 180 is just pi. And then working backwards, pi radians divided by pi times 180 is 180 degrees. So degrees times pi over 180, radians times 180 divided by pi, those are our two conversions. So let's play with a couple of those real quick, and then we'll call it quits on this video. So we want to convert 135 degrees to radians. So if we look at our formulas that we just saw, we have to take 135 degrees, multiply it by pi, divide by 180. So if you simplify 135 over 180, you're going to get 3 over 4. So we're looking at 3 pi over 4 radians. And if you think about what a 135 degree angle looks like, it would be right here. And we saw earlier that that's going to be the same thing as 3 pi over 4. So now we want to convert 9 pi over 2 into degrees. So we want to take our radians, 9 pi over 2, multiply it by 180, and divide it by pi. So if we do that, our pi's are going to cancel. 180 divided by 2 is going to turn into 90. 90 times 9 is going to be 810 degrees. So that would mean if you were going to go around the circle more than once, so that'd be 360 degrees, 720 degrees, and so on. So to get to 810, you're going to have to keep going around the circle. So we can go around more than once, just keep adding 360 each time. So we'll call it quits on this video, and we'll see you in the next one.